This is PN532 Programming Part 4. In this video, I'll be using the NTAG 213, 215 and 216 tags. This video, I'm going to cover the extended frames and the incommunicate through command, which I have covered in the previous video. However, I'm going to take more commands from the 213 tags and show you how to use the incommunicate through a PN532 command. So you can see my PN532 board connected to the USB to TTL cable. I'm going to connect. So we're going to use the NTAG 213 screens. So first I'm going to read this NTAG, the 213 tag. So as you can see here, we have to send a number of intag exchange command to read all the pages starting from page 0, page 4 and up to page 44, and each read command reads 4 bytes. So this is a very simple command. We have seen this command already. So if you count here, probably I'm using this command 10 times to read the 44 pages. So I'm going to next use this NTAG 215. You know that 215 and 213 they are the same, they have the same structure. The only difference is the memory capacity. So I'm going to activate and read the entire tag. So here also we'll be sending number of the read page command as well. So as you have noticed here, this takes more time than NTAG 213. So NTAG 215 has got 134 pages altogether. So likewise, I'm also going to try next the NTAG 216. This has got much higher memory than 215. So this has got totally 230 pages, and as you can see here, we have been sending so many read commands. Now, is there a better way to read? Is there a way to do the reading fast? So there is a command, and which you can see in the instruction set of or the data sheet of 213, 215, and that is called as the read fast command. So in the documentation is very simple. For this command, you have to send the starting address and ending address, and you get all the data from between these two addresses. So as you can see here, you get n times, if any number of pages you have to read, n times 4 bytes you get. So using this, we can try to read the entire tag in just one single command. However, there is a limitations which I'm going to disclose very soon. So I'm going to use this fast read command, and we know by now any command which is not defined in the firmware of PN532, we have to use the incommunicate through command, and we have seen this incommunicate through command in the previous videos. So what incommunication through does is, whatever command you put here is sent as it is to the tag. So I'm going to read this entire tag now, but starting from 213, but this time using the fast read command. So I'm going to activate. So every time you place a new tag here, you have to activate it. So I provided a checkbox here. It says use fast read. So let's see what's going to happen when you hit read tag. So looks like that this is much better than the previous read operations. The entire tag content, we are able to read it in just one single command. Now I have to go through a couple of things here. The firstly, the command that is sent to the tag. This is the in communicate through command, and as well as we have to refer to this because this in communicate through starting from D442 followed by the entire command here. So we have done the D442, and anything after this must be the command of the tag. This must be the read fast read command. And if you see the documentation, the command for fast read is 3A. So we have got 3A and followed by the two addresses, start and end address. And I know that 213, the start address 0 and ending address is 2C, and you can see 2C. This is the command, and we know that this is the or the checksum and the post humble thing. Now we have, this is the output. Now we have received right from the byte 0 of page 0 to the byte 4 of the last page. So all this information, okay, it's belong to the tag, and I've just decoded and probably I've split this data into 4 bytes each, and I'm showing this in this grid. So this is much better than reading every page, using a separate read page command. So I'm going to try this time with ntag 215. Something more interesting you're going to see this time. So read the tag. Oh sorry, now what happened here? I did not activate. So activate, just clean this. Now read the tag. Now look at that. Here we are not able to read everything in one single command. Now that's what we're going to see why it is. So if you look at here, I have sent the command, the fast read command, to read from page 0 to page 134. That's the last page. However, I did not get all the data. I just got part of it. So because of this, I again send one more read fast command from starting from page 63. So what we have seen here is you can read a maximum of 63 pages at a time. So I'll tell you why. I'll tell you what's the reason behind that. So I have to send more than one fast read command. However, the last fast read command I'm sending from 126 to 134. This is much better than sending 10 or 20 separate read command. So this structure, it looks very familiar. However, this is an extended frame. So let's go. I'm going to open this PN532 manual and look for. I always search for preamble. Okay, start from the beginning. Okay, now what we have just witnessed is the extended information frame, where you can see the preamble is 0f followed by, see here there are 2 bytes in the length m and the length low, this MSB and the lower byte, and before this there are 2 FFs, and this is the fixed values of FF and checksum. So we just witnessed one example of a long or extended frame, and this frame, and there is some more important information here. The reason why we could not read the entire tag is it's a limitation in the firmware. The firmware can read only up to 265 bytes. Okay, plus probably one extra byte here. Now this is limitation. This is the maximum number of bytes we can read at a time. Even though you use a fast read or any other read command, you cannot get more than this number of 264 number of bytes. So if you compare this with what we have got here, now you can see that, so here up to here it's all fixed, and the length is in this and this byte. So 1 times 256 plus 2, so we got 258 bytes altogether from here to here. So out of which we extracted all the things we are supposed to ignore. This FT, this the D543, followed by the status, and this is where our actual data starts, and this is again, this ends with the DCS and the preamble. Now this is also the first time I'm seeing the extended frame, and here as well we try to read everything from 63 to 134. However, we could not read everything. We just read the next 63 pages, and that is page from 63 to 125, and the remaining 126 onwards. So if you can, if you see here, I can use fast read command even to read a single page. So you just have to mention the start and end address. Now we just this is much better than reading sending 20 commands. Now where do we use this? It all depends on the application. Probably if you ask me, these type of commands are used when you write a endf data in a tag. So let me try the entag 216 as well. So I'm going to activate. So read. Now this is much faster than it was before, and you can see here, in order to read this entire 216 tag, I have to send 4 times the read fast read command. So you got the first 63 pages, the next 63, and all these I have the extended frame. And here what you can see here is see, this is a response from PN532. So the PN532 decides whether to use a extended frame or whether to use a normal frame. So if the data from PN532 is less than 256 bytes, it uses a normal frame. Otherwise it uses the extended frame. So again, in everything here after that, it's just as usual. And if you want to know more about this ntag 213, 215, 216, I've got plenty of videos in my channel. Please you can watch it. So next I'm going to show you all the commands in these 3 tags which users in communicate through PN532 commands. In the last videos I showed you how to use a get version. So it's very easy now. You just have to note down this command, and that's all. Just stick it with the in communicate through. The read command, this is a normal command. This command number 30, which is supported by the firmware. So in order to use this read command, you'll end up using the in data exchange command. The fast read we just saw. The write, again, this is part of the firmware. So I'm just going to say what exactly I mean by saying it's part of the firmware. If you go to the documentation, page 66 and 66 and go through in data exchange, this 127, and if you look at, go to the MeFair mode, MeFair tag, and this is all these commands are defined inside the firmware. So we saw 30, A0, A2, And the next is the compatibility write, and this is also part of the firmware, and we have seen this, and we have seen this probably, or and I can show you here. So compatibility write is to, if you see the documentation, there is a command called writing 16 bytes A0. If you go back to this 213 tag, it is again, this is A0. So again, as the documentation says, in fact, this write operation is a two-step process. So I have shown the working of this command in my CR95HF video. However, because this is a part of the firmware, all these multiple steps is taken care of by the firmware. So even though this writes a single page, we have to send 16 bytes, out of which only the least significant 4 bytes are returned and the remaining are not used. Okay, let's give it a try. So I'm going to try this on my this 213, which I've been using when change the password. So activate, read the tag. So I'm going to write something to page number 6. So I'm going to write a number this time, say 25,000. I'll make it more. And this time, before I write, I'm going to put a tick here, and let's close this and give a write. Okay, so the write failed. Sorry, I did not notice that this tag is protected by a password. As you can see here, this column says W, is write protected. So let's reactivate and hope I've not changed this password. So I can read it, not a problem, because read is not protected. So the password is I think 100 is a decimal number, decimal. So based on 1000, activate. Yeah, so authentication is fine. I'll come back to this activate command because this is also a part of incommunicate through. So here, so let's clear and write this page number 6. We agreed to write 25 followed by some zeros and put a tick on the right, and we are sending we are supposed to write only the 4 bytes. So click on a write. The write is successful, and if you see here, we are sending the command A0 followed by the page number 06 followed by the 4 bytes, these 4 bytes, and followed by all these dummy zeros. Now finally we got the success code, and the A0 is part of the firmware of PN532, so we have used this in data exchange command. The next is a read counter. So this is again this is I'm not going to explain what this command does. Our main objective here is how to use this command in PN532. So here the command is 39. It's a read counter command followed by the address 02. So it's nothing nothing complex here, just pass 39 and 02 with the incommunicate through command. So however, there is a small configuration here. It is the counter is enabled, is I'm going to enable that. So this is a part of my entire 213 videos where I explain every bits of this section. I'm not going to protect the counter, I'm going to write. So I've written this configuration. So that's alright. I think the counter probably is active only after you restart. So I'm going to take out this tag again, place it back, read. Okay, so we are still using this fast rate, it's fine. If you go to the counter, say read counter, now this tells us how many times we have read this tag. So the read count doesn't increment for every read operation. It just how many times, probably how many times we activated these tags. This is a very good information. So it's very good, very useful in your the smart posters or no, so many applications. You can use this. So let's see what has happened here. So the command that's gone here is 423902. We know that 3902 is a read counter command. 42 we know it is a in communicate through command, and the output is this is a 32 bit, probably. 1 second, is this it's a 24, sorry, it's a 24 bit counter. So this is a 3 bytes counter from here, and this is the lower byte. And if you just try to read it number of times, or you can read any individual pages, this read doesn't increase at all. So you have to I'm going to reactivate and read this time. So the read did not increase. Probably you have to read, I think, the very first read. Yeah, so I think it means, so any first read will increase the counter. So that is about using the read count command using in communicate through. And we I think we have seen this read signature in my previous videos again. So now we are more comfortable. You just had to pass 3600, you get 32 bytes of data. Password authentication. Okay, this is something important, because these tags are popular because of this password. For I use in my project, because this has a password. And the one more tag which is very similar in structure to this, which also has a password and locking and all the stuff, that is the MeFair Ultralight EV1. So in order to use this password authentication, the command is 1B followed by the 4 bytes of password, and the output of this is the value of this packet. And I can try here. So go to the password command, and we still it's the password is still 1000. So close this, and these messages, okay, they are not right because they are from the previous screen. So let me close this and try again. So activate, and in fact you don't have to read this at all. So I'm going to authenticate with value 1000, authenticate, and what I'm doing here is, as soon as authenticated, I'm reading out whatever data you get. I'm just inserting a dummy page, and keep in mind you can never ever read the content of the password and the pack values. Even though you try to read, you get all the zeros. So what has happened here is, again we saw it is 42 is in communicate through command, 1B and E8. I think 1B actually is the password. Yeah, 1B is the password authentication command, followed by the 4 bytes of password. So again here it's a lower byte. So it's a lower byte here. You can see this in hex now. If you click, you get in hex here. It's 3E8. So if you go here, it's sorry, E8, sorry. So yeah, obviously now what, this is the lower byte and this is the higher byte. Okay, so I've mentioned here. So the higher byte is first, followed by lower bytes. Okay, now E8 is lower byte followed by this. Now this is the password, and the password is successful. You got this as a 00 followed by the pack value. The pack value at present same as that. So To make it clear, probably I'll change the pack value to change it to 2000. I want to write, so the pack value is written, and this time I'm going to authenticate again. So you got this pack value, which is D0 followed by 07. Okay, and finally we saw this. I think we have covered all the commands of ntag 213, 215, 216, and we just seen how these commands are used in PN532. If you just have a quick look at this structure, the memory structure, and you can see that the structure wise all three are identical, just the user memory is different for three different tags. So that is all I've got in this video. So if you like it, please give me a thumbs up, and you can please subscribe to my channel as well.